Welcome back to this How GitHub Builds GitHub talk. And thank you for inviting me to give this talk to you. My name is Sebass van Boxel. I'm a solutions engineer at GitHub. This means I help out companies when they want to use GitHub or when they want to improve their software development lifecycle. I've always been a developer, and in my role I speak to a lot of different developers, so I talk about quite a few different development practices. Also within GitHub, we talk about development quite a bit, and that's also what I'm going to talk about today. And that's my favorite Octocat. We have some Octocats with us, so if you want stickers, there's my colleague, Ada. She can give you all the stickers you need. We have many. That being said, before I'm going to talk about how GitHub builds GitHub now, I want to take a few steps back and I want to tell you how this all started. Because when GitHub was created, we didn't really do that with the intent to become this multi-billion-dollar company we are now. We didn't do it with the intent to be acquired by Microsoft. That wasn't really the idea, but hey, it happened. GitHub is created by developers and for developers because collaboration back in the days was quite difficult. There was no real way to propose changes to a software project. You had code hosting websites where you could download source code, and you also had version control systems. But if I wanted to contribute to a project, that was really painful, and GitHub was created to solve that. At least that was the idea. So often when you, and maybe some of you still know this, when you wanted to propose a change to a software project, someone else had to download that change, had to see what it did, and then you had a conversation over private email on how it could be improved. Some projects had public mailing lists, and maybe some of you are still subscribed to some of those public mailing lists to discuss what was happening in the software project. And that wasn't working that well, so we created GitHub to collaborate on code, to make it easy to propose new changes, test new code, etc., etc. That was the idea. Why I'm telling you this, it's going to make more sense in a couple of slides, but it is really important to get a bit of perspective. GitHub today, as you already know, I don't have to tell you this, but we're hosting almost every major open source project. Docker solutions, container solutions like Docker and Kubernetes are hosted on github.com. Web frameworks like Angular and React, you'll find them on github.com. And we've created this network of open source projects that all rely on each other, one way or another. Many of these open source projects are nowadays adopted by big companies. PayPal, Apple, whatever, they all use GitHub, but they also contribute back to those projects. And because of those projects, we are here where we are today, because probably most of you cannot really do that work without a tool like Ansible, which is created by a company, but it is open source, and that's the reason we can use it. And it makes our life much easier. Data science tools are also hosted on github.com. So that's where we are today, and why this matters is because of this, because this is what GitHub is today. GitHub is a highly distributed company. Almost in whatever team you work at GitHub, you will probably have another colleague that is working in a different geographical location and a different time zone. It sounds challenging, but it works pretty well for us. I took this screenshot a couple of days ago, and 67% of our workforce is remote at the moment. And because of this, we have to adopt all those principles that are used in open source. We created GitHub because we wanted to make open source development easier, but in the end we have to adopt all those principles ourselves. And that's exactly what we're doing now. One of the key things we do at GitHub is all our communication is in writing. You write everything down. It is async and direct. So if I have a discussion with my colleague in Amsterdam, we will write it down. So even though we maybe assume it isn't relevant for our colleague in Japan, he or she can join the conversation at any moment in time. And this is what our culture is today. Also, everything we do internally at GitHub is public, so we don't use any private message when it isn't needed. We only use private messages if it's really about something that is private, like a one-on-one with my manager. We can be pretty sure that isn't relevant for anyone else. And besides that, everything is public for anyone, so anyone can join in at any moment at github.com. Also means that all our source code is public for everyone at GitHub, and this is really important because besides having all the communication out in the open, people can contribute at any time, at any project that is important for them. If I see a bug on github.com or in one of the other projects, I can propose a change and we will discuss that change. And because of that, we don't have any silos. People work in project teams, but they also contribute GIS Plus to other project teams. And to give you an example of how that looks today, we use Puppet to manage application and infrastructure at GitHub. And we don't have that many Puppet experts within the company. But this is quite an active repository. We merge over 50 pull requests a day. And those pull requests are not only created by Puppet experts or engineers. Anyone in the company that feels like they can contribute to something else within GitHub, they can do it. So by now 35% of all GitHubbers have committed to GitHub/Puppet. This includes people who work in the support team, it includes sales engineers. If people see that something can be improved, they probably will improve it. And they can do that because we try to take away all the friction possible that is in between them checking out the code and proposing a change. Last but not least, 67% of all GitHub engineers have contributed to this repository by now. And you will find the same numbers on our github.com repository, which is our core product. I'm a solutions engineer. I contributed to github.com as well. And you see that many people contribute to it all the time. So, why does this work for us? We want to enable everyone to participate in whatever software project is important for them, or whatever we can use their knowledge. We try to take away all the possible friction, and that means we basically think of two things. We think of checking out the code and proposing a change, and everything that is in between those two things, we try to take away or minimize all the friction possible between those two steps. We use obviously best practices when we develop code and when we build code to make it as easy as possible for developers to do that. And I want to dive a little bit deeper into how we do this, and I want to start off with a really obvious example, but a lot of companies or software projects don't do this, and it's a bit of a shame. Every project you will find within GitHub has a README file that basically explains the purpose of the project and how someone can set it up on their local machine so they can easily contribute. It explains what the project does and what is expected from a possible contributor. And why this is so important is not only in open source development, but also if you work for a company and you join that company, you're probably eager to learn what they do and how the software works. You don't want to open up every repository and dive into the code to see what the code does. That isn't efficient at all, and it can easily be solved by just having a README. On top of the README, all our projects on github.com have a contributing file, so besides knowing what the project does, we also tell people what we expect from them, when they contribute, what should be in a VR, what should be tested, etc., etc. An obvious example, but let's dive a little bit deeper in other things we do. Scripts rule them all, and it was mentioned in the last talk as well, and I think it's really important that new hires, or people that want to contribute to an open source project, can set up their local development environment within minutes. Because at GitHub we develop a lot of software. GitHub.com isn't the only repository we have. And we have a lot of potential contributors. And with everything we do, we think about how can we convert those potential contributors into actual contributors. I think, if I speak for myself, but I think many of you have the same experience, we've all worked at a company where we joined and it took hours or days to set up our local environment. That isn't efficient at all, but it's also quite demotivating, because when I join a company I want to contribute and I want to play with the code. If it takes days and I have to ask my colleagues all the time, hey, I'm trying to set this up, can you help me? Hey, I get this error code, please help me out. That's why we have a consistent bootstrapping overview across all our projects. Whatever major project you will see in GitHub, it will have this overview, and it works all the time. But if it doesn't, we always list a Slack channel where people can ask for help. But for the major projects we have in GitHub, whenever one of these scripts exits with an error code, it will automatically open up an issue in GitHub and assign the right people. So the right people will know immediately that someone is struggling with setting up one of their projects, and they can help them out. It adds all the details of why it exited with an error code, so people have all the context, and I as a new hire don't have to think about who do I have to ask if this isn't working? What do I have to do if one of my Docker files isn't working as expected? And this works really well. We have some example scripts on GitHub/scripts to rule them all of how we do this. But we do it extensively, and we invest a lot of time in setting up these scripts, so we don't have to invest time in debugging machines over and over again when someone starts. And I think that's also one of the highlights of the talk we had before. Just make setting up a machine as easy as possible. So now you know how to contribute and how you can run it in local development, but you need to know what kind of project management people use in a project team. This is basically all we do. We use GitHub issues and we use project boards. And because we believe in taking away all the friction possible, we approach project management pretty lightweight. So as a developer, you only have to think about what's in the issue, where you can discuss a proposal for a new change, and what's in your code. That's basically it. No story points or anything else. I think this one is really important. And we have many of these things. If you fill api.github.com/AutoCAD, you'll find many things we do at GitHub. So by having this in place, developers only have to think about developing and creating new features, fixing bugs, etc., etc. So now you can actually contribute to a project in GitHub or to one of our open source projects. Yes. This one is probably pretty familiar for all of you, but I want to guide you through it really quickly. Most companies either use a Git flow or GitHub flow. If you don't do that many releases, a Git flow makes a lot of sense. If you do many releases, like we do, you probably apply the GitHub flow. Let me guide you through it because it's doable. You check out your branch, you create a feature branch, and you add commits. You work on your feature, add commits like all of you do. Then you open a pull request, and I think this is the most important thing with every feature we develop within GitHub. We try to motivate everyone to open a pull request as early in the progress as possible. Whether it's a work in progress pull request or just some task, open a pull request so we can open up that discussion. Because the earlier you do this, the easier it is to implement feedback. But not only that, in the time I worked at a different company and I worked on a feature and I fully fleshed out that feature and I was confident that this was the way to go. Then I opened up the pull request, and probably I had one or two colleagues who came with a brilliant suggestion, which meant for me that I had to do it all over again. Because I didn't inform anyone what I was working on, and especially if you work distributed, it is really important that people know what you're working on. So whenever we start and we do our first commit, or we did a couple of commits, we open up PR. So we can open up the discussion. And you add more commits. What's also really important about this, at least with GitHub, is sometimes you work on a feature together with a colleague and you have a discussion with a colleague on what is the best way to implement something. That discussion is really useful, but if you work highly distributed, many people do not know what you've discussed. And when you open up that pull request, probably you have another colleague that will open up that same discussion again. So that's the reason we do everything in writing, and all the conclusions from a discussion like that, we write them down in the pull request, so everyone knows what is going on. This will probably look familiar to you. Let's see. We discuss code changes. We integrate a lot of third-party products.
Sorry, can I ask something in the middle,
Yeah.
or do you want to
go ahead? Okay.
I was wondering how much of that sort of discussion do you capture in your commits? So how much of that are you going to rewrite in commits? As in,
that's it. What discussion, whatever you name this, discussion or collaboration, you do this together. So you will come to a conclusion what is the best thing to do as a team.
Sure.
And a pull request also isn't about, it isn't really about getting feedback. A lot of new hires are afraid to open up a pull request because that is the moment they get feedback. It's the moment where you collaborate and come to a conclusion that a part of the code should be refactored, but another part you can keep.
Yeah.
So there's no rule for that.
But do you write, so when you in the end come to a discussion,
Yeah.
do you sort of summarize that discussion in your commits? So do you rewrite your commits so that the subject of the commit actually contains the discussion, or
No,
the
not
conclusion
really.
of the discussion?
No, it's part of the PR discussion.
Okay.
We don't rewrite those commits. If we add commits, we use a relevant title, of course,
Mm-hmm.
but that's it.
Okay.
We add new commits to it. Yeah. We use protected branches across all our repositories on GitHub, which means no one can deploy a PR that hasn't been approved and doesn't have clean CI. They cannot deploy it, and they can also not merge it into masters. So most of the time we require a minimum number of 2 reviewers and a minimum set of CI that has to pass before you can actually deploy your code to production. And in a minute I'm going to tell you on how we do those deploys to production or to any other environment. Because that's quite interesting, I think, how we do this at GitHub. CI, we use CI a lot. 44 CI builds have fired of checks for CI builds have fired after this PR. We automate as much as we can, and we rerun CI on every new push. It includes unit testing, functional testing, linter testing, integration testing. Anything that can be done automated will be done automated in a test, because it gives confidence to new contributors that they know that whatever they're working on is working. So they're pretty sure, like, okay, what I'm doing is fine, that all the tests are green, and all the things that are relevant for humans, high level stuff, that can be discussed in the PR. We use Jenkins for CI, and probably you're not familiar with this layout. We built a custom layout on top of this because the layout that we had a couple of years ago wasn't really the way to go. But besides Jenkins, we also use Jenki, and Jenki is an open source tool library, but it's basically the connection between Jenkins, GitHub, and our chatbot. And we use chatbots a lot. I'm going to tell you more about it in a minute. But it gives us highly relevant information because all the feedback from CI directly feeds back into a pull request. So developers don't have to open up that CI tool, scroll to thousands of lines of logs to see that one test that is failing. They can directly see it next to that code, and they can also see what line is failing, so they can immediately fix it and there's actionable data in it. They can rerun a test from within GitHub if they want to, and that's also the vision that GitHub has. We try to integrate all those tools within GitHub, so it doesn't really matter what tool you want to use. You can do it from within GitHub. So Jenkins and Janky, and let's say your PR gets approved, CI is green. Now you can do the actual deployment, and at GitHub we always deploy to production from a feature branch. This means that we always deploy from a feature branch, and only when a feature is confirmed in production and it is stable, then we merge it into master. And by having this in place, we ensure that master is always our stable release branch. Whatever happens, we can always re-release master. So if someone, for whatever reason, and it luckily doesn't happen that often, releases faulty code from a feature branch, or it has a performance regression we can only find out in production, we just release the latest master and everything is fine. How we do deployments.
I'm sorry, I have a quick question.
Yeah.
How do you prevent features that have been merged into master before the feature branch was merged? How do you prevent that feature branch from overwriting the previous ones?
Good one. Before we do a deployment, we always merge the latest master in the feature branch.
Okay.
That's basically the way we do it. Also, if there are conflicts or features influencing each other, we will find out this way. This is how we do deployments, and you see Google. I'm going to talk about that in the slides, but we don't have an extensive CD pipeline at GitHub, not at all. We don't move code from test to acceptance to production. No, the developer is fully in charge on when they want to release a feature to what environment at any time. And we use the deployment API within GitHub, and that basically gives us this. At any moment in time, we can see who did what deployment to what environment from within the PR. Because this information is super relevant for everyone, because at any time you want to know what feature is released, where it lives, and where I can see it. So it doesn't really matter to what environment I release. It is immediately visible in the PR. I can click on view deployment to see the actual output. I can, and this includes screenshot, but if a deployment has failed, I can also see it. So it has that status check available as well from within the PR. Yeah. Before I'm going to dive deeper into this, I want to talk a bit about chat. We use it for all our ad hoc communication, but not only that. It's the one place where everyone is in one spot, and yeah, we really use it for everything. Work, socializing. We have dedicated rooms for the Amsterdam office, for example. We have dedicated rooms for people who like cats. Anything you can think of, there's probably a chat room you can join. But most importantly is we use it for all our operations. All the operations we run not via our terminal, but via chat. And this is because we want to make it visible for everyone at any time what is happening and what is being executed. If I have a colleague in Hawaii, she's the only GitHub in Hawaii and she's in a different time zone, we don't want her to work or execute all the operational commands via a terminal, because no one has any clue what she is typing and what she is executing. Slack is our shared terminal. We do our deployments via Slack, we get information about our deployments via Slack, and we really use it for all the operational commands we do. This is a really simple example where a colleague of mine asked which environments are available to do a deployment to. Grafana and Datadog are implemented as well, so we can see the number of deploys.
You use Datadog?
Yeah, we use Datadog. Yeah. Question?
it's telling us that production has been locked for 30 minutes now. So every time a production goes out, the entire production pipeline is locked for as long?
No. Nowadays we don't lock it that often anymore, but with certain features we do. And this is an example of where that happens. We also use deployed range because we, on average, it's in one of the slides, but we deploy 60, 70 or 80 PRs a day. And we try to do that in batches, so we can deploy them together. That makes more sense. But sometimes there is a queue, because something has to be verified and we don't want anything else to be pushed to production before that is verified. And then it is locked. Now locking an environment also happens via Slack, by the way.
And that's all managed by U-Bot itself?
U-Bot and the developers. Via U-Bot, yeah. U-Bot, by the way, it's an open source library, so you can use it. Many add-ons are developed for U-Bot, so you can implement traffics or anything you want. You can do anything with U-Bot. Merge with master when it is confirmed in production. Deploys to production 57 hundreds of times a week. Yeah, we do many deploys. That's why we use GitHub flow. And developers, I think that's the most important thing. We give a lot of responsibility to our developers, and they can deploy whenever they want to. But it is visible for everyone. U-Bot, there we go. We execute almost every thinkable task with U-Bot. Not only operational tasks, but we also can ask U-Bot to tell us who is in the office at the moment, what is the weather, etc., etc. But this is really the glue that keeps our company together, because we don't only use it from a cultural perspective, but also from an operational perspective. Of course, there are people with certain permissions that can fall back on their terminal, but luckily that's never needed, because we want to use U-Bot for everything, so everyone always knows what we're doing and what someone is working on. Chat is our interface. Actually, Wired wrote a nice article about this a few years ago. It's the hardest working GitHubber, and many companies use U-Bot nowadays as well, because especially with distributed companies, this is really useful to have chat as a common interface. Besides that, we've built an internal tool called Haystack. It's where developers can monitor their deployments. So you can see who did the deployment. And they can track code changes at any time, and they can see how it influences performance and how it behaves in production or in any other environment. Datadog feeds into this information, by the way. Besides this, and I don't have a screenshot of that now, but we also have a developer confidence dashboard. And that developer confidence dashboard, a lot of data is feed into that. For example, also Twitter. So when someone does a deployment, he or she can immediately see that that shit is hitting the fan. But that's still something a developer has to check manually. But we also have U-Bot again. Whenever someone does a deployment and it doesn't work out, or there's a performance regression, U-Bot will notify you and say, hey, what's up? You just did this deployment and this is the result. Here we just have a warning, but if shit really hits the fan, U-Bot will open an issue for you. Because the last thing you want to think about as a developer is opening up an issue when you should do a hotfix or when you should do a rollback. You just don't want to create that issue, you want to fix it. And you also don't want to collect all the relevant information, because U-Bot can do it for you. It shows you the output versus the expected output, and it gives you all the information that is relevant for the hotfix, so you only have to fix it. U-Bot is super intelligent the way we set it up. And we use it for everything. Yeah, I can go on for days what people use Hubot for. But it's mapped to all our operational commands. Yeah. One other benefit of Hubot is that it works on your phone, and we don't want developers to work when they're out of office, but we also don't want them to be dependent when something important has to happen. So you'll always have your phone with you, and you don't need your laptop or your terminal to execute an operational command. You can do it via Slack. Everyone can see it that you did it, and also everyone can help you out when it doesn't work as expected. So I know Amsterdam Dance event is at the moment. When it doesn't work as expected, you can fix it from wherever you are, even in a car. That's it for Hubot for today, but I have a few more tools I want to show you.
I have a question about Hubot. So
Yeah.
you use one single channel for everyone?
No.
Because I imagine you have like several hundreds of employees.
Hubot is a member of almost every channel.
Yeah.
We do have separate channels for operational commands, but when sometimes I really want to execute a Hubot command that is relevant for a specific channel, and then I execute that command in that channel. But Hubot is a member of almost every channel within the GitHub Slack workspace. Not in all of them. Where Hubot is needed, you can call Hubot. Any other questions?
One quick question about Hubot, this is security-wise. So you guys make the decision to completely offload the security aspect of all of your operations, whatever you want, to Slack, essentially.
Yeah.
Has that bitten you in the ass yet, or?
No, not yet. But it is a good question. But no. Also because the way Hubot works, we use SAML SSO for Slack and GitHub and anything else. So whoever executes that command should have the right permissions to execute that command, and Hubot checks that. I think that we wrote an article on our engineering blog about how we actually implemented GitHub within GitHub. We also have Flipper. This isn't something we made at GitHub, but we use it a lot. We create a lot of small features and with short-lived feature branches, but we do not always do that. We had a conference last week and we shipped some complex stuff, and then we use feature toggles. And we use Flipper for that, to ship features to limited audiences. So often we staff ship our features first, and after a week, after 2 weeks, we ship them to all our users. Or we do public beta or private beta, or we completely don't ship a feature, so it's there but nobody can really see it. We use Flipper for this, and we've built our own UI on top of this. It's also connected to Hubot, so everyone can always see what feature toggles are switched on or switched off. What I find most interesting is Scientist. Maybe some of you are familiar with Scientist, but as a developer, refactoring is super difficult. Not only because of the fact that you have to refactor and you have the technical aspect, but also because it's hard to find out whether the refactor was an actual improvement. Maybe you have to convince your manager that the refactor you did actually delivered a performance improvement. How do you find out with a refactor? And Scientist basically is a pattern, and it's used across different programming languages. We use it in Ruby that enables you to do this. With Scientist, you basically build a new bridge next to an old bridge, and whenever you verify that the new bridge works as expected and it is better than the old bridge, then you tear down the old bridge. And that's just a metaphor, but this is how that looks. Scientist works with code blocks, and with those code blocks, we always execute the legacy code next to the refactored code, and the result of the legacy code will be returned to the user. So the user will always see what he or she has always seen, the result of the legacy code. But at the same time, we execute the refactored code and compare the results of those two code blocks to see whether the refactored code works as expected and whether the performance has improved. Because most of the time when you do a refactor, you do it because you want to improve performance, and that is most important. So we collect those metrics, and whenever we're confident that the refactored code is actually the best code, then we remove the legacy code. And this isn't always the case. Because of scientists, we found out that the refactored code isn't always the best code, so then we have to remove the refactored code again and just use the legacy code. But scientists helps you to find this out and show it to your manager that refactoring is really important.
Is performance the only metric for better code in this?
So you have metrics you can test, of course, which is the return value and performance, but you also have code style. But that's not necessarily something we check with scientists. That's something we discuss in the PR and in CI when needed. But we use scientists mostly for the return value and performance. Again, we built an interface on top of this, connects to Google. Everyone can always see what we're running and what we're doing. Yes, so as I already mentioned in the beginning, most of the people at GitHub work remote and in different time zones, and this works pretty well, but we also realize that software development still is a human activity, and you need to build trust before you can work together as a team. And we try to enable that wherever it's possible. So our developers, but also all the people in other teams come together a lot. We have an annual summit, but we also organize mini summits with separate teams. We organize mini summits where people from different teams come together to work together on a project. We have hack weeks. This actually is one of the hack weeks we did. We go to conferences together. We give talks like this. We sometimes have booth duty at the conference where we just talk about what we do at GitHub. So whenever it's possible and whenever people ask for it, we enable them to come together and work on something. And most of the innovations that happen on GitHub, and also some of the innovations we shipped last week, last Tuesday, were created at one of those hack weeks, or were started at one of those hack weeks. So that works pretty well. Also, everyone who joins GitHub first has to onboard in San Francisco. We really believe in the culture we have, and it's really useful to be in the middle of it for at least 2 weeks to find out how people work together and what is expected from them. So everyone who joins GitHub has to go to San Francisco for 2 weeks. We also, maybe this is really obvious, but with GitHub, so we try to contribute back to many libraries. So we're a core contributor of the Git library, of course, but we also core contributor to the Ruby on Rails library. And we work together a lot with different companies. So we work a lot together with Google Cloud, Azure, obviously nowadays. But I think that this is a nice example, because at GitHub we've built the Electron framework, and Atom is based on the Electron framework. Not that many people use Atom nowadays because it's Visual Studio, which is also built on top of that Electron framework, and that's also open source. And on top of that, we've built a GitHub integration, which again integrates with Visual Studio. So this makes the circle round, I would say, of contributing back and working together on projects that help us as a developer. I already mentioned this, but what I've talked about today is pretty high level. It's really about the culture we have at GitHub. If you want to dive into the really technical stuff, how we manage our data centers, how we improve our platform, how Google pod is implemented, check out github.engineering.com. This is live for already a few years, but this also really helped us to attract new talent. So if you're looking for new talent in your company, an engineering blog really helps. Because since we've launched this, we have really seen more and more job applicants at github.com. So many tech companies have an engineering blog. Mainly because of this nowadays. It's a way of they can be vocal about what they do, and a lot of our engineers also like to write about what they do. So to summarize this, the engineering culture we have at GitHub is fully based on open source principles and everything that happens in open source development. We try to enable collaboration wherever possible, and we try to take away friction wherever possible. So we try to make it as easy as possible for people to contribute to whatever they want to contribute. This is not only internally but also to our open source projects. We enforce code reviews so we can be sure that the code we have is the best code, and we automate what we can. We give developers a lot of ownership, and this requires a lot of trust, and this is the reason we do all those come-togethers and mini summits. That's it. This is my GitHub handle and my Twitter handle. I do not tweet that much, but check it out. Any questions?
I have two questions. So the first one is that we kind of do you use any agile process with the names Kanban or Kamikaze?
Kanban-ish. So we have project boards, but our developers don't spend that much time in those project boards.
And who decide what are you gonna or what is gonna be the next feature? Is a product owner?
There is a product owner. So we have product teams with a product owner, and they prioritize stuff, often together with developers and often together with input from solutions engineers who work together with customers.
Is a board for the strategy or whatever?
Yes, but we give a lot of freedom to our developers, and product managers tell them in a way what has priority, but you also see that developers contribute to other projects that aren't necessarily relevant for their own project team, just because they see something can be improved.
So you don't know exactly when things are done because
there is a timeline, and tickets are created whenever we want to work on a feature, so we know what we want to implement when. But no, we don't have story points, for example. No, we don't have the whole agile Scrum process in place. And that maybe has to do with the fact that most of the power in GitHub still lies at the developers. They really decide bottom up what has priority.
Of all these people, what is the percentage of deeply technical people mix and people that are not technical but help with the process? Because I saw there were around 400 people in the company.
900.
900. Do you have an idea of how it's divided?
So you mean really engineers?
Yeah.
Because even our support people are actual engineers, or they have.
Yeah, these one are engineers for me.
Those are also
Yeah,
engineers for
yeah.
you.
So people, technical people that can comment in Kurikas, can deploy a feature.
I think 70%.
7. Okay.
Yeah.
My second question is where is this thing running? Is it AWS? Is it on-premise?
We have our own data center.
Okay.
Yeah. Or we have multiple data centers.
Do you have any plan to move to Azure now or something else?
No. First of all, the deal hasn't officially closed yet, so we cannot have those. We're not allowed to have those conversations with Microsoft, but they do have a lot of data centers that we can use. So in the end, it will probably make sense to move some of those things to Azure, but also because we optimize really low-level stuff. We'll maybe move to the Microsoft data centers, but not necessarily to Azure.
So there is a DevOps mindset in place. Have you ever been on call as an engineer to actually fix the shit in the night or restart?
There are people on call. I'm not one of those people.
But there is
But
the
people,
ops team.
yeah, we do have an operations team. It's fairly small because a lot of the operational knowledge also lies with the developers. But we have those data centers that need to be maintained.
Yeah.
So people are on call in those data centers as well.
Can you go one slide back? Yeah, the point right at the bottom, require mature and respectful behavior. Really important, but also really hard to maintain for an organization with 900 people to have like a common sort of framework around that, right? To go, this is what we find acceptable and this is completely not acceptable. How do you handle those things? Like, do you have a code of conduct or all those
We have a pretty extensive handbook.
Okay.
Then again, it's the stuff in that handbook is quite obvious. When someone isn't respectful, you can at least point to that handbook like, hey, these are the things we agreed on when we joined GitHub. So what is the reason you're not behaving like that?
Well, these obvious things, like, usually aren't the problem, right? Because those are the, 90% of the people around you or 99% of the people around you should say, look, this is not acceptable.
Yeah.
But the problem usually occurs in like PRs. People are a little bit too aggressive or a little bit too whatever. Like, how do you work
People
with
are
those kind of
really
issues?
good at giving feedback. People do that within GitHub, and I've seen it happen. Of course, it happens in every company. That people are a bit too aggressive in PR. Of course, happens at GitHub as well. But the interesting thing is that that discussion about that aggressiveness that people maybe do not even realize also takes place in their PR, and that works pretty well.
So you hire decent people, right?
You try to.
I think so.
Selection at the gate. I mean, that could be a reasonable. Like, that's a really good strategy, of course. But
Yeah.
it's good
I
that you
think-
say
I
these
think-
things. It's good that you.
I
that
think we
doesn't
hire
happen.
people with the same mindset,
Yeah.
and that becomes more difficult when you scale up.
Yeah.
But my interview process, and maybe you've experienced that as well, it's at 2 or 3 interviews that were not focused on any technical stuff or any skills, but really about how do you approach people with a certain identity or people who behave like this. And you can fake that in those interviews, and you can tell them what they want to hear. That was also one of the questions I asked in one of those interviews. But they try to filter at the gate.
But that's the thing. I mean, you can lie, you can cheat whenever they ask you those questions. But because of the surroundings and all your coworkers have the same mindset, if you get there and you're the fake one who tries to be nice, you won't feel at home. Because it's like, oh, okay, these people are really like that. So, or you're going to change and you're going to say, I'm going to be in a good place as well, or you follow them on. You won't feel at home for yourself. Yeah.
And I mean, this isn't meant as a commercial talk about GitHub, because of course we also have stuff that I think, why do we do it like this? I think a lot of things are going to change in our management layer because of the Microsoft acquisition, but we really didn't have a CEO for a couple of years. And that's also what a lot of people complain about, so a lot of stuff will be improved at GitHub as well. Yeah.
Do you have large features? And if so, how do you handle those?
Large features.
Yes.
So yes, this week we shipped a thing called GitHub Actions, which enables people to do CI, but also micro optimization within GitHub. This is one of those things we release on a feature toggle, and it's also released in phases. So we think about the strategy when we build a new feature to split it up into smaller features. But in the end, it will be one big thing that we need to release.
So the short-lived branch for small features still applies to that then?
Wherever possible, we try to do that. But if that isn't possible, we use that flipper tool to use feature toggles.
Yeah, nowadays there are, for example, books like Accelerate or people that are trying to analyze successful companies and see the best practices and see if there is a correlation. At one point, is this trunk-based development or short-lived branches?
Yeah.
And the question is, which of course, if you come from places where features are built, then you start being scared and there is the emerging hell.
Yeah, but still, you have the feature itself and the PRs. And you can have a big feature, but you can still split it up in small PRs. There's no reason not to do that.
In your experience, how long does a branch live on average, or a PR? How long does the conversation?
I don't know, we have data on it. I can look into it maybe after
It's not like weeks.
presentation.
Do you have a good feeling?
Oh, we have had PRs that were open for weeks, months. And the discussion went on, and eventually we probably closed it, or we came into. But that wasn't because it was a big PR, but because there was so much discussion going on around the PR. But we tend to not have any big PRs, and I think that is the biggest problem. Not that they're long-lived, but the fact that they're also big, because then you run into so many conflicts and issues. But I can't look into it.
No, the number was
Yeah. But most of the PRs are open for a day. Two. Maybe two.
I'm gonna check now. This week.
Ask people. Yeah, you.
Oh, yeah, you mentioned before that all of the conversation happens in chats and rooms and groups. So does that mean that email doesn't exist in GitHub?
Yes, that means that email doesn't exist. Only for external conversations, we use email.
Thanks.
So, how do you use it? Because in my team, since 1 year and so, we're using Skype first and then Slack now.
Yeah.
Then you start seeing a lot of colleagues that are pissed off because there is too much noise and they don't follow the conversation. And I guess
It's super for both, and we only use Slack for ad hoc communication.
for
Ad hoc communication when it's something. It's like us having a conversation now, but if it that discussion leads to something bigger, then we open an issue where everyone can.
so you make
follow
sure
it.
that technical things, for example, don't start happening a lot in Slack.
Yeah, often they start in Slack. Someone comes up with, hey, why do we do this? And then after 5 minutes, someone has opened an issue and assigned to white people.
And you continue. No.
Yeah. And we also try to correct people when they keep having this conversation in Slack. Because you lose things in Slack. I mean, the nice thing about Slack is that you can include links. That you can have links, so you can directly link to what someone has said. And also, if we refer to an issue in Slack to GitHub, it will automatically also pop up in GitHub. So we know someone was talking about that issue in Slack. So you can automate a few of those things, but try to limit the conversations in Slack to the conversation we're having now. We do use Slack a lot. Yeah.
Do you have the performance test as part of your continuous integration, and if the performance test fails, does it build the pipeline, and what tooling do you use on this integration?
What there's two questions.
Well, it's all about
Performance and
performance. It's all
sequence?
about performance.
Oh, yeah, we test performance. I'm not really sure what happens behind the scenes when we do that. But because we do quite some compute intensive stuff, and we have to optimize for those things, we definitely test performance.
And the scientists together?
We use scientists to optimize those things, and we feed those metrics into scientists. But the actual performance testing happens in CI or another tool with CI.
My last question, I'm gonna go. It's late. Do you have in your system any, I know it's a marketing label and I heard that, but any machine learning cool stuff to analyze what people are doing besides just the normal?
Yeah,
security things,
we started with that last year, and I know we've also announced something, but we're really focusing on semantic code search. It's one of the things, because we have a search engine within GitHub, but it's.
So I'm gonna be able to, hey GitHub, give me something that is gonna solve me this kind of problem.
Yeah, so you can visit experiments.github.com, And then we showcase one of the things, one of those things. So we're looking into that. And what we're also looking into is what you often see is, so we have this security scanning thing, which checks your dependency trees for vulnerabilities, and if there is a vulnerability, it will automatically notify you and tell you how to update that dependency. But we want to take that one step further and actually use all the data that is available on github.com in all those PRs, because people discuss those things out in the open, that something has a security vulnerability, but it isn't necessarily part of any database. And we want to use that data to feed back to our users if there is a security vulnerability, for example. Another example is, it's not really, it's kind of machine learning we use for that as well, is token scanning. What we're going to do is, you can enable us to scan your whole Git history and all your new pushes for possible tokens that can get exposed within GitHub. So whether you use an AWS token or Slack token, you don't want to have that in
But it's
GitHub.
for free on the enterprise.
That's going to be for free for all open source projects, and for private projects it's a paid service.
Yeah, because nowadays you can easily do a free password on the history and get a lot of password that give you access to.
Yeah, we did it the other day, and so many people expose keys, tokens, passwords within their own repositories.
Which I think scripts and bots that constantly are trying to fetch this from GitHub and then immediately use instances for Bitcoin mining or things like that.
Yeah, happens all the time. And we want to do something about it. So machine learning ties into that. Anyone else? Okay, in the back.
What's the typical delay between deploying a feature branch to production and merging into master? And is it hands-off completely, that automate happens without click on the button, or is it?
The click on the button happens in Slack, but it can take up to 1.5 hours. If there's a really busy deploy train and production is locked for whatever reason, it can take even 2 hours. But sometimes it can take minutes. It really depends. We're trying to improve that, but that is one of the things that isn't that we need to optimize, because we use one big monolith. So almost every release we do is part of that monolith, and that has to be re-released. And when doing that, you will get that queue, which on average is 30 minutes.
But is there a set of criteria that we'll only merge to master after post-deployment?
Say again?
Is there a set of criteria? Or if once you deploy to production, okay, it's fine, we merge it to master?
It's a set of criteria, so it has to be confirmed into production, and it doesn't. If it causes any performance regression or a bug is discovered in production, we will re-release the latest master.
Are those automated?
Yeah.
Right. So performance, you do performance testing on production?
Yeah. And for example, that Humboldt example probably also automatically triggered a rollback to the latest master.
Right.
So we try to automate that as much as possible.
Do you do any performance tests before deploying to production?
Yes, yeah. But performance testing in production is different than performance testing, so sometimes live. Yeah.
I assume you're a pretty flat organization based on your development distribution around the world.
Yeah.
How does it work in terms of management? So how do you create teams? How do you manage teams? How do you raise salaries?
How do we raise salaries?
Yeah, like who decides how big is the team?
It's not me.
Through Ulrike's.
The teams are quite flexible, and new teams are spawned quite often, and old teams disappear. So you will see that teams are working on a feature, on a bigger feature, and then they work on a new feature, and suddenly it's a bit of a different team. So in that way, it's really flat. We do have a few core teams, but not that many, and a lot of new teams are created all the time.
for example, do you have performance management and I don't know, yearly evaluation, and how does this work?
Yes. We have managers yes, we have managers, and I have a weekly one-on-one with my manager where we talk about. It only takes half an hour, and we do it via Zoom because he's in London. And every half year we have progression reviews, and we use this. It's called red fault levels within GitHub that basically defines what level you are and what salary you get. But I have no idea with my colleagues. and yeah. No. What do you mean? No, but I don't know, but we get salary raises once or twice a year.
It was not about salaries. It was more like how is it managed in your company?
Yeah, everyone has a manager.
That's it. There are no managers of teams.
There are product managers that manage a team, but more on a strategic level. But those are not the managers of the actual engineers. Those have a different manager.
Was it ever an issue that you are working remotely and, for example, you cannot gather in the same place and use a whiteboard and draw something or like point a finger?
Then we come together. So our developers come together multiple times a year. It's not a monthly thing because then it gets quite expensive, but it happens quite often. Anyone else?
So do you have a daily stand-up? You don't?
We have an async stand-up very selected. Because if you're in a different time zone, I'm more than happy to wake up my colleague in Hawaii. It's async. I know some teams have. My team has a weekly stand-up with the region, but not all teams have that. Yeah.
Your employer has a nice tool for whiteboarding remotely. It's called ServeCell. We have one at the office. It rocks. You should get one.
Okay, I'll check it out.
They're only 25k each, so.
Let's do it. Anyone else? Thanks.